code how we use this binomial expansion theorem to help us find out how to do the following problem. If you were to do this problem by hand, this is what would happen, which I hope you don't do. You would have x plus 3y times x plus 3y times x plus 3y. And what you could do maybe is you could possibly FOIL out the first two, FOIL out the second two, and when you do those, you would get two different parentheses with 3 terms each in them, and then you would FOIL out those two parentheses. Kind of a lengthy algebraic process. That's one way to do it. What we're learning today is how to do it without doing all that distributive property stuff, and here's how it works. See if this makes sense to you. Remember that I told you that math is the study of patterns. Okay? Each of the very first things that you see in each of these pieces is that Pascal's coefficient thing. It doesn't mean it's the ending number, but it means it was the coefficient. Like if you had something simple like x plus y being raised to the 4th power, then there's now a 3 in there. So the first thing I want you to see is that every single piece of this binomial expansion has 3 parts. You guys all see that? Yeah. There are 3 parts. The first part is that Pascal's triangle thing. Do you notice how in every single one of those, the top number is 4, which is on the parentheses the exponent. So the top number of the first parentheses is always the exponent on your binomial expansion. Don't write. The bottom number always starts at 0 and always goes up to the exponent. Or the top number is another way to say it. Always. What was the power on the parentheses to begin with?
4.
How many terms are there?
4.
Wow, good counting skills. Let's try again. How many?
15.
5. There's always one more than the exponent. Look at the powers on the second parentheses. The exponent always starts with the exponent and always goes down to 0. The third parentheses always starts with 0 and always goes up to the exponent. Look at the sum of the 2 exponents of the second and third parentheses. They always add up to 4, which is the exponent. I'm going to give you some time now to write, and then we'll finish the problem. Okay, so as I start to simplify, I can type the very first thing in each term, each color, into my calculator and find the answer. I showed you how to do that for NCR 0. Whenever there's a 0 on the end, you know it's 1. And then that's x to the 4th. 3y to the 0 is 1. For NCR 1 is 4. Because anything that ends in a 1 is always the number that's on top or to the left of the C. And then I would have x cubed and 3y. In the pink, for NCR 2 is 6. If you type it in your calculator, I have x squared, and 3y squared means the 3 is being squared, and so is the y. So that actually means 9. y squared. In the purple, 4, 3 in the combinatorics is the same as 4, 1. We just learned that number 2. So that would be 4 x to the first power, 3 cubed is 27, and y to the cubed is y cubed. And in the orange, 4 NCR 4 is 1, and then I have x to the 0, which is 1, and 3y to the 4th, 3 to the 4th is 81, and y to the 4th is y to the 4th. As I write my final answer, I'm going to simplify as much as possible. So in the red, I would have 1x to the 4th, or I prefer just to write down x to the 4th. In the light blue, I have 4 times 3, which is 12. And then I have x cubed, y to the 1st, and I write it as just y. In the pink, I have 6 times 9, which is 54, x squared, y squared. In the purple, I have 4 times 27, which is 108. And then I have x to the 1st, y cubed. Oops, wrote the 3 this time, or the 1 this time. And in the orange, I have 1 times 1 times 81, which would give me 81, and then y to the 4th. This final line is my answer for the expansion. So you'll notice that this took me 1, 2, 3 lines to do. The one up above might be the same amount. I'm not sure. I don't really think so. But as far as writing goes, I can do this one much faster than I can do other expansions. Maybe doing a cube or for sure a square, I would never use this process. But for sure, once I got to a 5th power, I would do nothing but this process. So we're going to try one more example. We're going to do number 4, and then we'll take a walk, and then we'll skip number 5 because it's the same as number 3, really. So at number 4, if I use the same technique as I was using earlier, I know that there are always 3 parentheses. My first parentheses will start with the exponent, have a 0 on the bottom. Whatever I see first in the parentheses goes in the first parentheses. Whatever I see second goes in the second parentheses. What's second?
Y. Negative Y.
Negative y. Very good, Joe. Negative y. Not y, negative y. And then on the top, I start with the exponent 5 for the middle parentheses and 0 for the end parentheses. Next, as I look at my first parentheses, the bottom always increases by 1. The middle parentheses, again, is the first thing that I saw inside, and the second or the third parentheses is always the last thing that I saw. The powers are now decreasing for the x's, increasing for the y. So now I have 4 and 1. Moving on, my third set will be 5, 2, 2x to the third power, negative y or minus y, whichever way you like to say it, to the second power. My next set will be 5, choose 3, 2x to the second power, negative y to the third power. My next set would be 5, choose 4, 2x to the first power, negative y to the fourth power. And my last one which I'm running out of room, will be 5, choose 5, 2x to the 0 power, negative y to the 5th power. And what I want you to notice again is there's always one more term than the exponent on the original parentheses. That in your first parentheses, remember there's always 3, but in your first parentheses, the top number is always 5. The bottom starts with 0, goes up to the exponent, which was 5. The second parentheses always contains the first thing in your original parentheses, The third parentheses always contains the rest that was in your original parentheses. And the powers sum on the last two parentheses always adds up to the exponent on the original parentheses. Not a process really in these. So looking at the first set of information, 5 choose 0 is 1. 2 to the 5th power is 32. And then I have x5. Negative y to the 0 is 1. In the light blue, 5 choose 1 is 5. 2 to the 4th is 16, and then I have x4. Negative y to the 1 is negative y. Remember that you're not subtracting y, you're multiplying by negative y. Very important. 5 choose 2 is 10. 2 cubed is 8. Then I have x3. Negative y squared is positive y squared. In the orange, 5 choose 3 and 5 choose 2 are the same, so that's also a 10. 2 squared is 4. Then I have x2. Negative y cubed is negative y to the 3rd power. In the purple, 5 choose 4 is the same as 5 choose 1, so that's a 5. 2 to the 1st is 2. And then I have x to the 1st power. And then negative y to the 4th is just y to the 4th. And then in the gray, I will have 5 choose 5, which is 1. And then 2x to the 0 is 1. And negative y to the 5th is negative y5. So this gets to be very long as far as all the work that you're doing. And then at the end, you just simplify. And your final answer will be 32x5 minus 80x4y plus 80x3y2 minus 40x2y3 plus 10 xy4 minus y5. So this thing is my final answer. Long process, lots of patterns. And number 6, this is where understanding the binomial expansion is way more important than knowing how to FOIL. Because what you'll notice is the power on there is a 12. So in order to figure this out, you'd have to multiply that parentheses out 12